Hello and welcome back. My name is Angell and I'm with State Supply. Thanks for joining me in today's video where I will introduce our new project we are working on here at State Supply. This is our steam trap demo project titled Hissing Gator. Like and subscribe for more content and follow-up videos to this one. The purpose of this project is to provide a better educational value to everyone involved with State Supply, whether it is for better educating our employees, our YouTube subscribers, or our customers at our in-person trainings. We hope to use this project to help simplify everyone's understanding of steam systems. The idea is to have a portable steam system. This will be achieved by putting the system onto carts that are easily able to fit through a typical doorway. To do this, we will be using a small electric boiler. It is a 3 kilowatt boiler that operates on 120 volt outlets and is able to produce 9 pounds per hour of steam. And due to the high current, will require a special plug that can handle 25 amps of current. The system must meet the requirement that it is easy to use, which is met by using a boiler that can be operated without a boiler license in Minnesota. And the system can be operated by pretty much anyone after explaining and following a short operating procedure. Glass steam traps will be used to allow for the operation of the steam trap to clearly be demonstrated and understood. To help visualize the project, I made some simple sketches. The sketch on the left, labeled Top View of the Display Cart, shows the basic layout and components of the boiler cart. The front view of the board shows the steam trap display. Starting at the inlet, we have a vacuum breaker to prevent a vacuum from being pulled in the heat exchanger. On a system this small, it is not a real concern, but we included it as good practice. The second component is the strainer, which helps to remove particulates in entering steam and condensate. It is recommended to always have strainers before your steam traps to increase the lifespan of your traps. Next, the isolation valves are there so we can control where the steam and condensate go, as we only have sufficient condensate to cycle one trap at a time. The double isolation valves before the bottom trap labeled UST are there as we plan to possibly remove that trap while the system is running. The glass viewing ports will be on both sides of the steam traps to show the operation of steam and condensate going in and condensate going out operation of the trap. Isolation valves are present on the back end of all steam traps to ensure proper isolation when desired. Finally, another vacuum breaker is present to prevent a vacuum during shutdown. Next, we have the water cart and heat exchanger. Removing energy from the steam is required for condensate to form, and with a boiler this small, we would like to cool at close to the maximum output of the boiler to create as much condensate as we can. It was determined that the system should be water cooled, as some of the common spaces we plan to operate the system in are smaller enclosed areas without dedicated cooling zones. This would make the rooms heat up quickly, as the heat would otherwise be given off to the air. By storing the heat in the water, we can delay the release of heat into the room. It was determined that approximately 2 feet of pipe in the worst case scenario would sufficiently cool the system. We plan to make the heat exchanger using a metal planter. If you'd like to stay updated on our project, please like and subscribe, and comment any feedback or suggestions you have.